Shuttle launches always make a compelling sight. On this trip, the payload was something rather unusual as it consisted of microorganisms. These microorganisms, or jellyfish, were sent up by NASA to help learn more about living in space. Although it looks easy floating around, living in space certainly has its problems. Before humans travelled into space, animals were sent while scientists checked their responses. When the first animal space travellers returned to Earth, they brought back enough information to safely send the astronauts into space. But even when NASA sent John Glenn into space to orbit the Earth in 1962, they still didn't know exactly how his body would react. On Earth, we feel the effects of gravity almost everywhere, but you can experience a similar environment to space by going underwater. Unfortunately, you can't stay underwater for long periods of time. Microgravity can be experienced on a roller coaster ride like this, or in one of NASA's special aircraft used to simulate it. But these only last 15 to 20 seconds a time. The beauty of Skylab was that the lack of gravity would allow many experiments to be made on the effect this would have on living organisms. Dr. Dorothy Spangenberg is the expert that made these experiments happen. She had been looking at jellyfish and had noted the similarities to humans. Dr. Spangenberg and her students had worked with jellyfish for nearly 30 years before the opportunity of sending them into space presented itself. She had researched jellyfish from around the world as more people heard about her interest. The more she learned about jellyfish, the more she knew NASA could learn a lot from them. Jellyfish are among the simplest organisms, but they have neurons or nerve cells similar to humans. They have sensors called gravity receptors located in their arms. These help them maintain their balance and know where they are going, like a built-in compass. The gravity receptors tell them that up is up and down is down. Humans have this too. To help us maintain our balance, there are gravity receptors located in our inner ear. After riding on an amusement park ride, you feel like you are going to fall down. That's because the motion affects your inner ear. Even after you stop, the fluids in your inner ear keep moving. This effect makes you dizzy. This type of motion sickness also affects astronauts in space. By learning more about the development and function of gravity receptors, scientists hope to be able to fight the effects of space sickness. By sending jellyfish up into space, they wanted to find out if they would react differently in microgravity. Would they still know what is up and what is down? Astronauts returning from space also suffer from calcium deficiency. Extended calcium deficiency causes osteoporosis, a bone disease, and many gum diseases as well. Here again, the jellyfish may help. Each jellyfish gravity receptor has a sac of calcium sulfate crystals, just as our inner ear has calcium-containing crystals. Another advantage to using jellyfish was their small size. NASA needed a small animal that they could study as they develop in space. More than 100 jellyfish polyps can fit on a dime. The jellyfish are also easy to study as they develop in distinct individual phases, and its gestation period is only 6 to 8 days. The jellyfish on board SLS-1 were placed in specially prepared bags filled with salt water and carried in an incubator to stabilize their environment. Just before they were launched, an iodine solution was poured into some of the bags to encourage the jellyfish's development. By the time the shuttle had settled into orbit, the jellyfish had passed their first test, proving that a microorganism can withstand the forces of liftoff. To help the jellyfish polyps develop into Ephira, the first stage of development, the iodine mixture was added to another group of jellyfish. And while the experiments were being conducted on the orbiter, simultaneous experiments were conducted on the ground. Both groups of jellyfish were videotaped as they swam, in the hope of recording any changes in their movement or behavior. One of the most exciting changes happened almost straight away. Remember how the jellyfish use their arms to pulse up and float down to feed on Earth? In microgravity, the jellyfish moved in circles, but they were still able to pulse and swim easily. In fact, despite being in a microgravity environment, the jellyfish polyps developed normally. After 9 days in orbit, they began to prepare the jellyfish for the trip home. One group was secured in the locker to be immediately studied after landing. The second group was preserved in a special liquid to be studied and compared to the jellyfish used in the simultaneous Earth experiments. Scientists spent more than a year studying the microgravity jellyfish and comparing them to the Earthbound group. The results surprised everyone. After swimming in circles in space, some of the jellyfish swam a little differently on Earth. However, most of them adapted to their normal behavior patterns pretty quickly. Scientists believe that their gravity receptors behave differently, which made them more sensitive to microgravity. It was discovered that the development form polyp to Ephira was unhindered in space, and they found most of the jellyfish to be completely normal. The experiments will result in more knowledge about human cells, the basic unit of life, and how they develop.